Okay, on this final section of the review, this is about complex expressions. You have to know how to add, subtract, and multiply complex expressions. So first is being able to tell whether it's add, subtract, or multiply. You can tell by the sign that's in the middle, so this one is just add on number 23. So when we're adding, you can think of this as being a positive 1, and we distribute it to the right. So this gives us positive 7 plus 2i. And then on the first part, we can just kind of bring that down, 3 plus 2i. Then it's all about combining like terms. So we add the real part with the real part, so 3 plus 7 is 10. And then the imaginary part with the imaginary part. 2i plus 2i is positive 4i. Now when we add i's, it doesn't become I squared. The only time you have an I squared is through multiplication. So when we write a complex expression, it's made up of the real part and then the imaginary part second. So this would be our solution. I'm going to go ahead and do the other one, the opposite. So we just did plus, so I want to do a minus example. So the minus example is up here on number 24. Same thing, except when we have a minus 1 right here and we distribute it to the right, that basically causes all signs to change. So we would end up with negative 7 minus 2i. And the front one actually doesn't change because there's no negative before that parenthesis, so we just kind of take it out. And then we combine the real part with the real part, so 3 take away 7, that's negative 4. And then the imaginary part with the imaginary part. Negative 6 and negative 2 makes negative 8, and then we just throw the I back on it. So that's our answer. The next example is going to be multiplication. So with multiplication, you're looking for two parentheses that are basically back to back. So it's kind of like they're touching. Kind of like a number 26. If you look at number 26, you've got two parentheses touching, so that's a multiplication problem. And on these type, it's a FOIL question. So you're going to end up doing 14 times 11 first. 14 times 11 ends up giving you 154. So this is positive 154. And you do 14 times negative 3i. 14 times negative 3 is negative 42 with an I attached to it. And then you distribute the positive 4i. So positive 4i times 11 is positive 44i. And then positive 4i times negative 3i is negative 12i squared. Now there is a fact that you guys have to remember about i's. An I squared is basically negative 1. So on this part on the right side where it says 12i squared, or actually negative 12i squared, this is the same as having negative 12 times negative 1, which we all know negative 12 times negative 1 is positive 12. The way I explain it to my class is, anytime you have an I squared attached to a number, all it does is change the sign to that number. And that's basically what's happening because we're multiplying by negative 1, and all it does is change the sign. So we still have the 154 from the front, and then we have the like terms right here in the middle. Negative 42i plus 44i is positive 2i. And since we simplified the I squared, this term right here actually goes together with the 154 now. So 154 plus 12 is 166, plus the 2 i's that we had left from the middle terms. So that's our final answer. So for the rest of this, I'm just going to put up the answer key so you can kind of try them on your own, and then you can check to see if you're doing them right. So here are the rest of the answers to the section on simplifying complex expressions. Now you probably noticed that this answer key has the i's first. Technically that's still the correct answer, but the standard form of complex solutions usually puts the real part, so that's the part that doesn't have the I first, and then the imaginary part second. So when you look at the test, especially when you're on the computers, it's probably going to have the I in the second spot. But I mean, if you look at these answers, technically, these are exactly the same as if you were to switch them around.